Hello, my name is Mariano Crimi from the IVP, and I'm the product manager of the BMS. And in this opportunity, I'll be discussing an EIB collaboration success story, which involves IVP's BMS and BTI's Breedbase development teams, and we think will showcase the power of BrAPPs. So, what's the challenge that we are trying to overcome here? Well, we think that one of the great challenges that EIB Module 5 has is the diversity of the different software development projects that is supporting, with, of course, a limited amount of resources. So one of the main objectives, of course, of this module is to find opportunities for synergies between the different development teams to avoid duplication of efforts, so that would, in turn, benefit the end users by getting new functionality faster, or with less cost or with more quality. One of the main avenues that has been taken to try and achieve these goals has been to introduce a layer of common interoperability between the different applications. And I'm sure that you're all familiar with BrAPI and the BrAPI standard. And we have to say that, this has been an instrumental tool to provide, the technical bridges that the different development teams need to build such interoperability. And we had good adoption, good support and maintenance of the standard over the years. But of course, the standard is a necessary condition for the interoperability and the collaboration to happen. But it's not a sufficient one, right? There has to be a concrete and specific intention to leverage BrAPI in the direction of collaboration, right? And that's why we think developing things as BrAPs is such a good idea. But what is a BrAP really? So BrAPs are standalone independent tools or widgets that can run on its own, and then that can be easily integrated with a larger system. The only condition for a BrAP to be called a BrAP is to be exclusively and completely BrAPI driven, meaning that it would rely only on BrAPI calls to get the necessary data to do whatever it has to do. And the goal of this paradigm is to encourage functionality sharing with the BrAPI community. Lucas Mueller's and his Breedbase development team had been, main drivers and adopters of this paradigm. They contributed, a set of very interesting tools for the users to be able to filter, studies, compare them, and also, do some pedigree viewing. And from the IVP side, we had a first taste of this paradigm by working on a project to incorporate one of these tools that Breedbase had developed into the BMS following this paradigm, and we were surprised with how easily we were able to add, this tool, which was a long-standing gap in the BMS in terms of providing visualization tools for the users to more easily comprehend the data in the system. And so we were really excited about the opportunities that BrAPs in particular would entail. Around that time, EIB Module 5 announced a set of sponsored short-term sabbaticals of approximately 1 to 2 months for the members of the EIB bioinformatics, biometrics, and data management communities of practice, with the objective to provide opportunities to different teams to develop new skills and to expand collaborations across CGR centers. So BTI and IVP realized that it would be a good opportunity to work together on a new BrAPP that could serve both Breedbase and the VMS and the larger BrAPI community. And so that's when we decided to apply for the sabbatical. And here's a little bit the timeline of that process. So in May last year, we applied for the sabbatical. In June, we got approved. Between July and August, both teams defined the details of the project. We leaned towards working on a field map BrAPP because we have, the Breedbase team already had a prototype in place, so we decided to build on that, given that we only had 1 month. Build on that to provide a BrAPP that we could release to the community and we can adopt ourselves. In October, a senior developer from the IVP, Nahuel Soldevilla, traveled to Cornell, Ithaca, and was hosted by BTI and Lucas Muller's team, working with them and with Mireya Flores, which was also a collaborator on this BrAPP. September, we managed to deliver the BrAPP, and October we were able to incorporate it into the VMS. So it was from May to October we had this process finalized. So the outcomes, we think that the outcome was very successful in that we were able to achieve a fully functional BrAPP and make it available to the community. As you'll see in the animation there, this application enables users to take a study layout and plot it against a satellite image of the field, of the actual terrain where this study would be planted. Once they do that, they can adjust things like the plot sizes, the orientation of the field layout, the geometry, and so on. And once that layout is defined in the terrain, the BrAPP stores the geo coordinates at the plot level once the user decides to save. This tool has been, as I said, incorporated in the different tools. And it was, of course, developed only once, and the code is available for the whole BrAPI community to incorporate it. You can see the GitHub link below the animation. And so it was a great experience. Additionally, this initiative became the rationale to make significant investments. On the VMS side, towards BrAPI 2.0, which is the newest version of the standard. It provided the rationale to extend our schema to support georeference information, and we were also in close collaboration with the BrAPI lead to define the requirements and refine the requirements for the 2.0 standard to consider this use case. In summary, our view is that BrAPPs and this sabbatical in particular are a great example on how different development teams and systems can collaborate in covering common functionality gaps in a very efficient and reusable way, and while learning from each other. So I think that would be it. Thank you for your attention.